Hey everybody, so today we're going to be working in 3.1 where we're specifically looking at how do we find solutions to a system of equations. And that is a situation where we have two lines and we kind of want to know where do they intersect or where do they interact. The idea behind this is that when two lines cross, okay, that is a really relevant point to us. It might be when two different business models are both profitable at the same amount, or maybe when our profit meets our income meets our expenses. So that's maybe a break-even point. It might also be a place where two airplanes, if we're not careful, would interact with each other in a negative way. We want to make sure things don't collide when we don't want them to collide. But we also might want things to hit each other sometimes. Maybe we want a basketball to go into a hoop, or we'd like a hockey puck to make it into a net. So those kinds of things, we need to know when do different things interact and intersect with each other. And so that point of intersection is really valid and really important to us. We're going to have some different ways in the next couple of class periods where we talk about how do we do it algebraically, but today it's going to be graphically. And this is going to be really straightforward and pretty simple. When it comes to finding a graphic solution, we were going to take two equations, like let's say for instance y equals 3x plus 1. And let's take another equation like y equals 5x. Sorry, I have to make this up in my head as I go. Minus 3. Yeah, these two equations will work out really well for us. So what first thing we want to do is try to create a graph of this. And so you can imagine, I'm going to go ahead and graph this first line by going up to 1. Putting a dot, and then slope says to go up 3 and over 1. So I'm going to go up 3 more over 1, put a dot right there at 1, what am I at, 1, 4, and then I can connect my dots with my line. Now some of you might be thinking right now, Mr. Welch, this is not going to go well. Your line's not straight, your dash marks might not be consistent and equal. And that's absolutely a big concern with graphing these by hand. With the advent of technology, it really helps. If you're doing it by hand, definitely want to use graphing paper whenever possible to help make this a little bit easier. All right, but let's go ahead and go to 5x minus 3, which would be down 3. Let's grab a different color for this. And then I'm supposed to go up 5. That's 1, 2, 3, 4, 5, and over 1. And my line will go through like that somewhere. Now, obviously, they're going to meet somewhere because their slopes don't match. One has a slope of 3, one has a slope of 5. They're clearly going to interact. Where exactly is difficult. And this graph, as much as it does show kind of a point of intersection, it is an issue. So if you're going to use a graph, you're going to do it by hand, really encourage you. Make sure you're using a straight edge, like a ruler. Make sure you're using graphing paper, if at all possible. It will help make it a lot easier. I want to show you how we can do this in the calculator. And then also how you can use like a Desmos or something along those lines. All right, so let's make this a little bit bigger. I have to move my picture here. All right. If we go to the y equals, which is this top left button, and we type in 3x plus 1, and I'm going to go to the next one, and I'm going to do 5x. There's my x key, minus 3. Then when I graph this, species. All right, we can see that they do intersect. There's a spot where it gets really thin. That's where they're crossing over the top of each other, but it is hard to see. Now I can zoom in. It is possible to do that. It's just not always that effective because you have to scroll over with your cursor to get to the general area, and then you have to press enter, and it'll zoom me in, and hopefully we'll be able to see the intersection. There it is. But I'm not exactly sure. It's around 1.9 and around 7. To be exact and to be certain, there are two options. One is to go to the table. This is probably the quickest. If we just go to the table and we look around, we're looking for the y value of each one to match. They use this x value, and we see the first graph is at 1 when we're at 0. The other's at negative 3. Those numbers don't match. But as we come down here to 2, we notice that both y1 and y2 are at 7. That must be the solution to our problem. So we can say the solution is 2, 7. The other option if I go back to a regular image of this graph, the other option, if I only have two graphs showing, is to do a calculation, which is right up here by the trace button. So second, trace, and I would look for number 5, an intersection. And it's going to ask me a series of questions. Is this the first curve? Sure, I press enter. Is this the other one, the second curve? Sure, I press enter. As long as you only have two, it's just enter, enter, and then it asks, do you want me to take a guess? The truth is the calculator is not guaranteeing you an answer. There are going to be variations and issues that will come up, but this works on 2 lines. It works so well that you shouldn't have to worry about it. When we press enter, intersection is 2, 7. If I were to use Desmos, it does the exact same thing. By Desmos, I mean desmos.com. It's a great graphing calculator. It just isn't one that you can use during your tests. So using the graphing calculator from class is definitely helpful in terms of just during a test. So that's what you're going to be doing today, graphing and finding that solution. Good luck, and hopefully that answers all your questions.